videos I sent out, and particularly the project files and then the book. I would really want you, like, if you have access, or rather if you don't have access to any of those, please indicate. Just indicate by typing in the chats area. I try to make available of all of those resources to everyone. I added everyone to a OneDrive folder and dropped everything there, added everyone, and I'm just trying to make sure everyone has access to those files. Like I mentioned the last time, correct, I have access to everything, fine, awesome. I'm really happy to hear that everyone has access. Now, beyond having access, the next thing would be something that's really very important is actually working with those files. Those, Tyler, you don't have access. Do you mind sending me your email address or something, maybe a personal chat or something? Or just shoot me an email. That would let me make sure I don't know what's going on. So that, because frankly, the course is not going to be very meaningful if you don't have access to those files. So please shoot me an email or something so that I make sure you have those files today. Now, for all of you that have the files, what's been your experience? Have you been able to go through the assignments? Have you been able to read through the content? And I say this because the last time I tried to establish that, the whole idea of making sure you go through all of the content is very, very fundamental to the course. And I'm not talking about being able to understand everything. That's beside the point. What's important is actually being able to go through the content. And the last time I used an analogy around language, when you begin to learn a new language, a lot of things are strange. It's like when you started driving for the first time, things are going to be strange. It doesn't matter. What does matter is that you just keep doing what you can, and wherever. I'm not sure where the playground files are. Okay, so while I'm responding to that, Christian, the playground files, right, are in a folder in OneDrive, and that was the folder I was referring to. It's a project folder. And there are 4 subfolders in that specific folder. One of them is named values, and which is where we are starting there, because the course is divided into four parts. And for each of the parts of the course, right, we have a subfolder. So that subfolder has the playground files, and all you need to do is just click on those files, open it up, and then as you read through the book, it gets you to the point where you need to do the projects in the files, and then you go through that. Now, if I was running a class where you had like maybe 10 to 25 people sitting in a room, that would be a completely different scenario. But we have a situation where all of us are remotely dispersed. And like I said, the best I can do is to serve as a guide. I'm going to make sure you get to every single thing you need, and then make sure you're not stuck at any point. So if at any point you are stuck, you reach back to me and I will help you get unstuck. But there's no way it's going to work, frankly, except you are actually doing the work. It's like trying to become good at math. There's no way to get good at math. You don't just get taught math. You have to practice math, and that's how programming is, and particularly Swift programming. So that's very important. So for anyone that's has had any problems, once everyone drops off, I'm going to stay here and make sure, even for those of you that haven't gotten access to the files, whatever it is, I'm going to make sure we get access. So because we're still in this teaching phase, what I'm going to do is kind of slow things down a little bit to make sure everyone catches up within the past week that's gone and this week, so that everything that you need to know around the basics you already know. And then after, by next week, we are going to speed things up a little bit. But I don't want anyone to run into problems. And it's literally like trying to have a kid unable to read, right? And the class is just progressing and going, like, and they are now in the 3rd or 4th or 5th grade, and the child can't read. So I want to make sure everybody is able to do their alphabets, do all the reading, so that once we get into the higher classes, things wouldn't get kind of muddied up. And while I do that, I'm appealing to those of you that already have very good background in programming. You just have to be patient with us. And then the other thing you can do is, like, the resources I provided the last time, it's in the slide. You can actually go ahead and start to do a whole lot of other things. But this background is really, really very important to make sure everyone is carried along. Like I said, there are minors in this class, like 12-year-olds, and then there are also professors in this same class. And that's what the whole point is. So, any questions? Do you have any questions? Is anyone experiencing any kind of difficulty? You have any problems, questions, or you got stuck somewhere and you think it's something that might benefit every other person? Just feel free yeah, Benjamin, thank you for sharing that. Awesome. Yeah, because if you go through the book, you can actually find those files, but I wanted to make sure everybody had access to them right on in a folder, so that you can easily reach the files. But you can look at that link and see if you can get access to the link. So, and that's in the chat area. Benjamin just helped share that file, or it's a zip file for everyone that wants it. So that's where we are with this. So I'm going to pivot and then go into the first unit. Like I mentioned, there are 4 units in this class, and we're going to go into the units. Because of the transition, I noticed that the videos progressed at a different rate than the book. The videos are good to watch. Awesome. That's something you can also follow along in the, and you're very correct, Kelvin. The book, like I mentioned, right? That book is meant for everything between people from high school trying to learn Swift up to people working in Apple, right? That have been introduced to the course. That's what everybody does. So what it does is there is a gradual build up, so that you have very good foundation, so that at the point you are you want to go into more serious things, you already have the basic foundation to be able to navigate. So I'm going to share my slide right now. And as I share my slide, I'm going to tell you exactly what we are going to be doing today. Can you see my slide? Okay. Just a minute. Okay. Just a minute. I want to make sure I have this here so I can. Just give me a minute, folks. Admitting. Okay, so what we have here is what we're doing for today, the class. So the last time, one of the things I did was to make us all aware of exactly what's involved in this course. And what you have here, explorations, right, is literally what our focus is for this class until sometime in April. Now, these are the basics of programming, but then as you begin to go through this course, you actually begin to dabble into, it's mostly going to be focused on Swift. I talked to us about what Swift was the last time, and then what Swift UI is. where a lot of what you're going to be doing around here is going to be stuff around Swift. And then we are gradually going to be dabbling into a few things in Swift UI, which is literally where you're beginning to build interfaces, right? You're beginning to put things together, and it's beginning to look like an app. All of that is going to happen, and it's going to culminate in you actually building your own app. Wow. Well, that app is not going to be, some great app that has everything that you need, but it's going to be an app. It's going to be kind of functional before you begin to progress into these other areas where you begin to, for example, pull data from other resources, from sensors, from the cloud, and from every other place out there to be able to build apps. So our focus is here. Now, today we're going to be starting with values. And then when we're done with values, we're going to move to algorithms. That's just what they are called. As you go through it, you're going to see what we have going on up to the fourth unit. And as I mentioned in the project file, each of these units, right, has a subfolder, and those subfolders have files in them. And those files are the files that you need to follow through and actually do the physical work. They're very easy. They're straight to the point. If you get stuck, feel free to come to me, and then I can help. Even if it's something that is so complicated I can't help, I can call on folks within Apple to provide some help. But I mean, at this level, most of what you have there is very doable. So that's unit 1. So the book starts at a particular point where we literally just talk about what's programming. Programming is essentially using a computer, receiving inputs, right, from with a computer and producing some kind of output. Now, inside the computer, you have a program, and the program is literally, what tells the computer how to handle that input that is being given. Now, and there are all kinds of ways you can receive input, like your keyboard, right? You type your text and information gets into the computer, into the program. The voice, you can just speak through a microphone and information gets into the computer, and then a program can modify it, analyze it, and give you some kind of output. That's literally what happens with this. So the programming is literally about you being able to build the programs, right, that receive inputs and then output something. But at the end of the day, what you receive is data. Data is not just about numbers. It's not just about characters. It's about, think of folks that are blind, right? Text to braille, right? So just by filling things around, or you have your screens, right? Your very smart screens, and you can literally communicate with the computer through the screens. That's all what this is about. So that's one of the things that's how the book literally starts, and you can tell that this is very, very basic, but then we're going to begin to ramp it up as we go. Now, data is literally a collection of values. Now, if you look at this, right, we have attributes. You just imagine a table, right? And we want to gather data around a guy called Johnson Peters, right? He has a name. His name is an attribute. He has a height. That's also an attribute. He has a weight. That's an attribute. And he has an age, and that's an attribute. But these are the values of that attribute. And this is practically one of the most common ways, right? Most programs organize data. Being able to understand the organization of data, right? And being able to know how you feed in that data into the program is literally what would make you a good programmer, right? So data is essentially a collection of values, right? And that data is literally what you need as inputs into your program. So like many programming languages, right? Swift particularly has a way of expressing and manipulating data. Different programs have different ways of organizing, expressing, and manipulating data. So when you see people trying to people that already can code in, saying, Python, wanting to learn Swift, for example. I mean, most of what they already need to know, they do know. But then there are certain variations and differences, right, that folks like that just want to be able to figure out about Swift, and in no time they'll be up and going, because most of the things about a lot of these programs are essentially the same, with little variations and differences. And those variations and differences are some of the things we would also point out in this class, especially for some of you that are trying to do transitions. Now, one of the most important things about programming is naming. And like I mentioned, I'm not going to go too far into the classes today. At some point, some of those videos we had looked at the last time, I probably want to share some of those videos so that we can see how some of these things run. And at some point, so so that you still, because I know a lot of us showed up in the class to be able to build apps, right? So I'm going to throw in a particular video or a bunch of videos if we have the time, where the guy we talked about the last time was actually trying to build a code that's called We Split. And all it was about, and like I mentioned in the first slide, I guess, where I said you're going to build like the user interface. That was essentially, more like what he did. So I hadn't started pulling data from different places. So that's going to be part of what we do in the rest of the class if we have the time, so that we can allow every person that hasn't completed these assignments or hasn't even found anything to make sure everybody is properly onboarded. And then next week, we are going to go off to the races. So naming is critical to understanding and communicating all the data around us. So what tends to happen is somebody's name is, say, Johnson Peters, right? Now there are, if I wanted to figure out, there are Johnson Peters probably has 1,000 different attributes about him, right? The length of his fingernails, where he comes from, like his hometown, the number of siblings, the number of brothers, blah, like you could talk about all kinds, even identifying things about him, right? His fingerprint and all of that. Most of these would actually be very distinct from every other person. His iris, some of the biodata from him, all of that are the things that make up the guy called Johnson Peters. In fact, if there are 100 Johnson Peters around the globe, Johnson Peters is still going to be very unique amongst all of the Johnson Peters. His DNA profile, all of those things are probably going to be very different. But guess what? There's something we do as humans. Instead of trying to figure out all these details about Johnson Peters, all we just do is give him a name. And his name is Johnson Peters. That's it. And behind that name, right, which is like a paywall, you have 1,001 other attributes about Johnson Peters, right? That's like what we do in programming, where we feel a need to name things and hide a lot of the other attributes about whatever it is that we are naming. And in programming, that's actually something we call abstraction. And I'm going to talk a bit more about that. I don't know how quickly. For those of you that are familiar with object-oriented programming, abstraction is one of the 4 cardinal principles of object-oriented programming. Now, naming, like I said, is critical to understanding and communicating all of the data around us. Naming lets us put a name on a person, that should be a comma, place, or thing, instead of repeatedly thinking about all the details about them. So part of Swift, like several other programs, would be creating names. And these names are things we call identifiers. So this is an example of what I was talking about before I begin to talk about identifiers, right? Nadia. This is a lady called Nadia. Everybody says, hey, her name is Nadia, right? But you don't know all of the details about Nadia. But guess what? You know, is someone called Nadia. If she fills out a form, all you have there is Nadia. You don't have all the other details. But then you could literally click, if her name is clickable, you could literally click her name, and all of a sudden you have all these troves of information about Nadia. So naming, as you see on the slide, is a form of abstraction. Abstraction literally helps us hide the details about something so that we can focus on things that are more important. And in programming, how you do that is by creating what you call identifiers, right? Identifiers are literally names that you put on things. And these are clear and very descriptive names that show the intent of the code. And I'm going to show us examples. It's better to show examples of what I mean. So for those of you that are very green when it comes to coding, when you go see a piece of code, you just see words are hanging all over the place and you're wondering, what are these words about, right? I'm going to show you an example of something you're going to repeatedly see in every code, which is what we call identifiers, which is a code word way of putting a name on a person, place, or thing, right? Now, naming, as you see in the slide, is a very important skill in programming. Now, good programmers are very good at creating good identifiers, and there's a reason why you are careful about how you create these identifiers. So what's the importance of good identifiers? One of those things is that, and I'm going to show us examples of identifiers, right? One of the important things about good identifiers is that it makes codes easy to read. That's reason number one. Because they are very clear and very descriptive, once you see an identifier, a good identifier is one that once you see it, somehow you are immediately able to relate to what it means. Now, if I say a lion, the first thing that comes to your mind is the king of the jungle. It's a dangerous animal. It's a fierce animal. It's something that lives in the wild, right? You just know that not because anyone has said anything, but because you have the word lion. So I go there. So it makes codes easy to read because you are essentially able to infer things, right? Without anyone telling you about what those things are. It makes it easy to also edit like years after, because some people, you don't do good identifiers, they come along and they do all of these codes and then they come back weeks, months, or years after and they have no idea what they have, the code they have written themselves. It's also very good. You know, one of the important things is when you do collaboration, a lot of coding or application development, you don't have just one person doing it. People work in groups, people work in teams. It's kind of important that people have some kind of convention around how they, you know, develop these identifiers. And then if you've done like come up with good identifiers, it's also now easy for other people to be able to debug your code. Now, there are two main types of or common types of naming conventions, right? So this is event handler, for example, is an example of an identifier, right? So you want to name something and you start with something like event handler. Now there are two types. You have the Pascal case and you have the Camel case. In the Pascal case, usually you use it's like upper camel case. And then the regular camel case is like the lower camel case. And what essentially does that mean? It literally means that names or identifiers contain multiple words that are co-joined. So in this case, you have event handler. Let's say I have two event handlers, right? One of them is short and one of them is tall. I could literally write an identifier that says if tall event handler, then equal to, and I'll put in their name as a string. Or I would say short event handler. That way I'm already able to make a distinction between them. If anyone shows up, right, and sees that identifier, tall event handler, immediately it says something to them. Oh, maybe it's someone that handles an event, and then probably that person is short, right? But again, one of the things I want to make a distinction about, and that's me talking about what an identifier is now to make a distinction between the Pascal case and the Camel case. Some languages, right, use the convention, general convention is the Pascal case, and then you have the Camel case, right? Camel case literally involves you starting off, the first word that you choose, right, you start off with a small letter. And then the next word and subsequent words, you use capital letters for them. So you might see an application where you have something like this and you're like, what's going on? It's literally an identifier, which is literally where you're creating compound words from two or more words put together. And usually they do not contain spaces or any kind of punctuation. And that's why even though event and handler are two words, there's no space between them. And that's what's going on there. So for Swift particularly, what I've found is that Swift, the general convention for people that code in Swift is usually the lower camel case, which is, again, where you put two or more words together, but the first word, right, starts with a lower case, and the first character or letter in each of the subsequent words are capital letters. Any questions? So the steps in creating the camel case, like I mentioned, is first of all, you begin each identifier with a lower letter. So I'm talking of speed of car. Maybe I'm trying to write something about the speed of the car, of a car, right? I'm going to start with something like a small letter for speed, and then off is capital letter, car is capital letter. These are all examples of identifiers that are based on the small case convention. So you begin each identifier with a lowercase letter, and then you use uppercase letters for subsequent or additional words that would follow. Now, like I mentioned before, that's conventional alert. Swift programmers generally use the camel case, which is the lower camel case. So once you have created an identifier, there is now a need for the identifier to be declared a constant or a variable. You need to be able to declare declare it either a constant or a variable. And we're going to talk about constants and variables. If you had gone through the assignments, you would have actually seen how constants and variables are used and why, a few other things about them. We're going to bump into all of that as we begin to ramp up our speed. Now, constants are specific data that is assigned a fixed value. It does not change over time. And I'm going to give us a couple of examples of constants. And variables may change over time. So once you have the identifier, the next thing you want to be able to do is to assign constants or variables to those identifiers. And then there are a couple of benefits for declaring an identifier as a constant. One of those is that it reduces the chance of you making mistakes. Sometimes it doesn't make sense. People ask, why do I have to? Eventually, I'm going to have us watch one of those videos where, the guy I showed you his video the last time talked a little bit about constants and variables. And then it improves the efficiency of your code. That's the next thing is, and how it does that is literally, in some programs, for example, C++, the compiler will literally put the value of the constant, right? Which is the value of the identifier that you have created. It literally puts it directly into the assembler instruction, right? And then that automatically eliminates the need for, for the program to read from memory all of the time. Those are, depending on where you are in the journey, those are not like right now your focus is probably not around the efficiency of your programs or all of that, but those are things that people that have a lot of experience and are already creating programs and applications, those are some of the things they worry about, because when you create these applications and programs, you want them to load very fast. You want to get your results very fast. Fraction of seconds might mean something. And that's example why, for example, people make some words or some identifiers constants. And some identifiers by nature are just constant. And that's what I'm going to be talking about in the next slide. So what's going on with this guy? So this is an example of, I need to shift this, right? This is an example, some examples of constants, and you have some variables, some constants. So for example, pi, like most of us, would have encountered pi in high school and all of that, which is a constant in mathematics, right? It never changes. So if I'm going to represent it in a code, right, I'm just going to make pi a constant. Now, pi is the identifier, and the value of that identifier is 3.14159, blah, 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 and the words continue, right? The numbers continue, right? That's a constant. It's never going to change in my code, so why would I make it a variable? So I just type something like let pi equals to this, and that's how, that way, just by saying let pi equals to 3.14159, I have created a constant. Now, some other thing that is not going to change. So if I'm writing a code about someone or about a group of people, right, and I want to put in their date of birth, your date of birth is never going to change. So it's going to be a constant. Your eye color, I don't know that eye colors change. A lot of things change nowadays, but I'll probably use that as a constant. My skin color isn't ever going to change, so I'm going to use that as a constant. Change itself, right, is the only constant thing. So if we can assign a value to change is a constant, right? For variables, so for example, what I'm going to have in if I make up an identifier and I call it something like my next dinner, right, is equals to, now I'm not going to make that a constant because what I eat for dinner is not going to be constant. If I decide to create another one about my place of work, it's not going to be, it's going to be a variable. So you get the gist. The president of the United States, right? If I'm writing a code around that, and I'm not going to make the president of the United States constant, I'm going to make it a variable, because I expect that every 4 or 8 years, someone is going to change. It's almost like the clock. It's going to change. It's going to change because America is not a dictatorship. So the expectation is that it's going to change. Therefore, if I'm creating an identifier that is called President of the United States, then that identifier is going to be a variable. And how do I make a variable? We're going to see some of that when we begin to look at codes, but I just want to lay the groundwork. What you're going to have is going to be something like var, V-A-R, var, then President of the United States. Now, remember that when I talk about President of the United States, and the goal is to use the camel case, for example. The gaps you see there between president and off isn't going to be there. It's going to, I'm going to start with president, small letter, and then a capital O for off, no space between off and the, and I'll use a capital THE, and then the next thing will be a capital U, and then S will be a small letter, and A will be a small letter, and that would be my camel case, which is the lower case camel case. And then once I have var, I would include that identifier, and I would assign it to something, which is I could now put in a string there where I say something like President Biden as a string or something. I've assigned something that I'm expecting is going to change. Now, if we've gotten all of that, remember how we've progressed on this journey, right? I told us about programming, and then from programming, I told us about naming and how important naming is, and then we proceeded into all things identifiers, how you identify things or how you name things. And then I said, when we name these things, we need to be able to associate them with in two broad categories. Either they are constants or variables. It's like someone being born, and the first thing you want to do is to identify the agenda. And the reason why you identify the agenda is because down the line, there are going to be a lot of legal issues that would require something about. So in fact, at the point where the child is born, on their birth certificate, you want to identify the agenda because it has both legal and cultural implications down the line. And that's exactly what's happening in programming. Once you create these variables, it's like you're giving birth to a baby, right? You need to be able to associate them with some kind of gender. They are going to be either constants or they're going to be variables. Once you do that, programming has started. And then the next thing, right, is now those, what you might call them now, identifiers would have to be mapped to some kind of value, right? And those values are essentially, they would usually be things like characters, right? Or strings, or they will be integers, or they will be what you call float, or double, or booleans, right? In almost every program that I am aware of, they have some combination of these different data types, right? And for you to become an effective programmer, right, in any of the languages, you need to be able to understand how that specific program manages these very data types. So part of what I'm going to be doing in this is walking us through these data types. And then by the time we walk through these data types, I would go back and show us some of those videos, pre-recorded videos. At some point, I'm going to be making some of these videos and putting them on a YouTube channel, and making them available to students so that we'll have our own collection and body of videos, because it gets kind of challenging doing all of the coding online real time. So Swift particularly supports 6 different data types. First of all, you have character. And when you say character, just take it from me. Character is just character, what you know to be character. But then, and I'm going to talk, I'm going to, after the generalities, I'm going to go down to look at each of them, and exactly we debrief on what exactly all of those things are, especially for those of you that are not totally familiar with these things. Now, you have character, which is usually represented with a shortcut of char. You have strings. Sometimes string is str. I need to make all of this very consistent. And then you have integer, int, and you have float, you have double, and you have boolean. Notice something about float and double. Float and double are almost like, they are literally numbers that have decimals. Double is also numbers that have decimals, but there's some kind of distinction, and those distinctions are things around the length of the data you're going to be dealing with, right? And then you also have Boolean, where things are either 1 or 0, or true or false. In fact, computers, unlike humans, we use the decimal system where everything is 0 to 9. And then we reset, and then we go back to 10 to 19, and then we reset, and we go to 20 to 29, and then we reset. But for computers, the way computers were, especially classical computers, not so much your quantum computers, things are set up in binary, right? It's either true or false. So Boolean or Boolean, right? It was some guy, I don't know what his name was it Thomas Boolean or something, that just focused on the on, off, true, false, 0, 1. It was something he just studied, right? And then, especially when it comes to decision making, when you write codes where you want to know whether something is true or false and all of that, the bool data type is something that can come very handy and is very important. So I've laid it out here, graphically, what the different data types are and examples of those data types. So character, for example, you see what character looks like. K, L, M, those are all, but that's not all, right? Something like, and even an emoji, right, is an example of a character. A space is an example of special signs. All of those things, right, are all examples of character, right? But the trick about character is, as far as I know, is that they are just one word. Or I don't know whether I would say it's one word. Words usually have more than one character. So it's just one character, right? Captured within a double quotes. That's the other thing I noticed about Swift too. I think a lot of times what Swift, unlike some programs that can accept double characters or single characters, most of what I've come to see is that Swift actually requires double characters. So look at the difference between string and character. Character is about single words. String is where you begin to throw those words together. Think of your kindergarten, right? The English language, you have your 1, 2, 3, 4, 5, 6 to whatever. You teach the kid that, and then you teach them about the 26 words of the alphabet, and then you begin to put those words together. Once you move away from just having A or B or C, and you begin to put those words together, they are no longer characters, they are now words, and that's exactly what's happening here. String, once you begin to put two or more characters together, that's how you get strings, right? And strings too, you want to put them in double quotation marks. And notice something else in the string. You notice there's a gap between hello and word. So space in itself, right? This space between the two words is a character by itself. So it's a character. And then you have integers. Integers are essentially whole numbers on both sides of the number line, whether it's minus or plus. So anything that is whole number is essentially an integer. And then you have floats. Eventually, as we begin to go through all of this, you begin to see how each of these words, each of these data types are used, and your ability to be able to do magic on your coding journey is as much the ability of your child or your cousin or your grandchild or whoever they are to be able to literally put those 26 characters together to be able to produce words, and then to pronounce those words, and then to one day begin to write sentences with those words, and one day begin to write books with those words. And then we go to float. Float has everything to do with decimal numbers, right? Anything that is no longer whole, whether it's 4.0, once that point shows up there, it becomes a float. Now you also see double is also the same thing, decimal numbers. But the difference with double is that double is able to accommodate more numbers on the right, like decimal numbers, which is like your point. Everything after the point, there's a certain length. I think double is able to, and again, sometimes I don't know whether it depends on the computer, it's able to accommodate up to 15 numbers after the points. Float isn't able to do that much. That's the difference between floats and double. Probably talk about that some more. And in some of these cases, I might actually be assigning videos that you can watch to help reinforce some of this knowledge as we proceed. And I already talked about Boolean, where it's literally very effectively used, particularly when you're trying to make decisions. So characters represent a single character string. It's used to create character type variables in Swift. Now, the variables created can only store single character data like A, B, C, a space, right? A special character, a 6, an @ and a hash, whatever it is. But notice you can't assign more than one character. So for example, if I open and close parentheses X, Y, Z, that ceases to be a character. It's no longer a character. That right there is a string. So once you put in something, by the time we type in that and we assign it a character, it will throw up an error because it's no longer a character. This is now a string. Look at this. So if I want to create a character, and then once you get the slides, you can literally get into Playground and play around with some of this code and see how it all plays out. Now, I want to create a character variable. The first thing I want to do is var. Remember the var I talked about? So what we have here, example of character, right, is your identifier, right? The prefix behind it is where this baby has been born. We want to be able to tell the hospital the gender of this baby. And for Swift, for this particular case, we have two genders. We have var, and then we have variable and constant. Now, if I want to assign, if I want to make this a constant, right, how you do that in Swift is you just type let, L-E-T. But in this case, what we want to assign is, it's a variable, so we're going to use var, which is literally variable that I mentioned earlier further up, which is the variable that we mentioned now here. So the short for it is var, right? And then you use your camel case, example of character. Notice what's happening: small letter, big letter, capital letter, no space anywhere. And then colon. And then I tell this system that this is a character, right? And then I say equals to, and I type out the character. And then I can print this out. If I say print out, it's going to print out this K. Try it out and you're going to see it's going to print out that K. If I decide I want to try my luck and I type in K-A-Y and put it in parentheses K, this thing is going to shout and tell you that that is not a character. So if I want to type in a K-A-Y, what I need to do is come here and I would write string, because what you have here is automatically string, not character. This is another example, same thing. If I did that, this is what is going to print out for me. And this is how you print. You essentially type the word print and put the identifier in a bracket, and then you click to print. Next thing, string. As I mentioned, it's just a series of characters that form a collection, right? It's used to store textual data. So for example, hello world, that's an example of a string. Now, a string, I don't know that there is any length to a string. I could write an entire paragraph, right? Provided I put quotation marks in the beginning and at the end, right? Put them within parentheses, it's fine. That's a string. And eventually, I'm going to show us, and of course, you're going to run into ways of combining strings, concatenation. We don't have that here today. and several other things on how you use strings. So it's used to create your string, or your str is used to create string-like variables, right? See below a string type variable. This is an example of a string type variable. Now, this is, remember this, I said you're trying to create your constant or your variable, right? Your let is what helps you create a constant. So what you're doing here is I'm assigning a constant. This is my, what you might call it now, identifier, in this case, place, right? And I'm literally making that place a constant. And then I'm assigning it. I'm trying to say that the type of this place is a string. It's not a number, is not a character, it's a string. Then I can say equals to, and I can map it to a particular place. And with this, I can't change it because it's a constant. So I can say equals to, open and close parentheses, and I'll write Colombia, right? I have created this entity called Colombia that's a constant. Now, there are two major ways, right, of creating strings, right? Two major ways. I was alluding to, when I said equals to, and then I put the quotation marks, that's an example of what you call the string literals. And then we have string interpolations, and I'm going to show us what all of that means, because eventually would be interacting with some of those things in some of the assignments, like the project files that you have. Now, string literal is a series of characters or escape sequences enclosed in double quotation symbols. That's what string literals is. I don't want to confuse you. I'm just going to explain what that means. Notice two things, and I deliberately put those things, I highlighted those things in the light or dirty brown, right? I said a string is a series of characters. That should be obvious by now. Because remember, I said characters are is just like your ABC, and a couple of other things like spaces, special characters, and all of that. Almost like what you see in your ASCII code, right? So once I begin to bring those characters and I put them together, right? Like hello world, these are all individual characters. Once I begin to put them together, they become a series of characters. So a string literal is a series of characters, or escape sequence. And I'm going to show us what escape sequences are, because you are also going to need to use escape sequences when you begin to code. And they are a series of characters. This shouldn't be or. I think I would say and or escape sequences, and I'm going to talk to us about what escape sequences are. But the important thing is that they are enclosed in double quotation mark symbols. So like this, let, by saying let, I've created a constant. So I give birth to first code output, right? And then I tell Swift that this baby I've created right here has a gender constant, right? And then I map it to this. Notice that unlike what I showed us here, right? String, I did not put anything like string here. I could, that's one way of doing it. I could just literally type string and say equals to this, and it will hold. But Swift already knows, once Swift sees a series of characters, right? And maybe escape sequences trapped within quotation marks, it automatically knows that what you're talking about are strings. So in this case, it's implied, right? So escape sequences could include things like, I was talking about the second part, escape sequences, they could include things like slash. So notice all these forward slash 0, forward slash back, which is like your backlash slash, this is /t /n /r /quotation marks and /single quotation mark. Now, let me use this as an example, double quotation mark. Imagine if I want to write hello world, right? And then I continued blabbing and saying other things, right? And inside these quotation marks, in real life, I want to type something that has a quotation mark around it, right? The only way I tell Swift that the quotation mark I'm trying to create does not automatically mean a string is by typing in /quotation mark. And then just by typing in /quotation mark, close quotation mark, and I'm going to show you that example, Swift automatically now knows, oh, the quotation mark you're referring to is not the quotation mark, because every time Swift sees these double quotation marks, it automatically thinks this is a string. Does that make sense? So let me show you this as an example. Let's say, for example, let, by now you know what let means. Let literally means that my college, which is my new baby, I want to be able to assign it a gender, right? I want to make it constant. So I say let my college 1 equals to, now, notice I did not also type in, I didn't put like your column, right? String equals to this. Just because I've put these words in a parenthesis, Swift automatically knows that I'm talking about a string. Eventually, when we have, when we get on Playground or something, we're going to check out, have instances of these data types and try to check out without explicitly identifying them. Once you go type in, say, type for my college 1, it's going to tell you it's a string because it's implied. So just even yourself, just by looking at this, you should be able to, with all of the explanation I've done, you should be able to just look at this stuff and know it's a string. So if I type this, let my college 1 equals to, open and close parentheses, USC is a great college, love it, right? And I end it here and I cover. If I print this, which is literally printing my identifier, look at the result I'm going to get. USC is a great college, love it, full stop. That's what I'm going to, so when you get home, try it. That's what you're going to get, right? Now, imagine if I wanted to type USC is a great college, love it, in quotation marks, because I'm trying to explain to us what these escape sequences are. It's something, so when you begin to do your assignment, it's something I encourage you to practice, because when you begin to code, you would need to do it. And you can tell when I talk about things like this, they are not things that you can be taught. You can be taught how they are done. You can be shown, but you need to practice them. So now, so this is my original quotation mark here. This is the other quotation mark. How do I tell Swift that I'm trying to make a quotation, put in a quotation mark when I print this? I use my escape sequence, this particular escape sequence, which is / double quotations, right? / double quotation. Then I include this in there, then / double quotation, right? Remember, this is your original quotation that makes it a string, but this quotation is your escape sequence, right? Once you do that, and notice now, look at this and look at this. What's the difference? The difference is essentially this and this. So all you have done is just put USC is a great college, love it, between the escape sequence on both sides. And boom, that's how you arrive at this. And that's where you see the distinction between this and this. Any questions though? Because I keep babbling. I don't know if People are stuck. So my intent is not just to keep going, but if you have questions, please, it's okay to unmute and just speak out. It's okay to text, type something, whatever is more convenient for you. So look at another escape sequence. An example is N. Where is it? Where is N? N. So that's a line feed. So imagine if you're typing and then you decide to go to a next line, because without that, if you just type all of this here, Swift is just going to give you this long sentence that keeps on going without breaking. So if I type something and I want to break, all I need to do is somewhere at the point where I want to break, I just put a /n. What that means is this is what, and I try to print this, it's going to say USC is a great college, break, and then it prints out the second part of the sentence, and I'm able to achieve that simply because I used /n. So there are a lot of these escape sequences that you need to get comfortable with, how to use them and all of that. And if you're looking for examples, there are 1,001 examples on YouTube. There are a lot of examples as a tour guide. There are a lot of examples on Google. But practicing and practicing them is what's going to make you comfortable, because at the end of the day, all we are trying to do here is to build the Swift part of the work, which is what you're going to have in the hood, the code that is going to be in the hood. Later, we are going to now build the interface, and then the interface connects to what's going on beneath, and then that's how you have an app that's functional and does things. The next part of strings, remember we've been talking about strings. I've talked about other data types. Now we're talking about strings. Then about strings is the second way you create. I talked about string literals, and I just gave us an example how you put quotation marks around sentences, around words, and that's how they become strings. The second way you can create strings is by what we call string interpolations. And you're going to see, I'm going to explain what string interpolations are all about. Now, string interpolation is an easy way to build a string from multiple individual pieces, right? Replacing one or more placeholders in a string literal. Now, remember what your string literal is. We already talked about that. When you have a sentence or a bunch of words, right, sitting side by side with each other and, put within quotation marks, those are what you call string literals. Now, replacing one or more placeholders, and I'm going to show you what these placeholders are. Replacing one of those placeholders within the string literal, helps you map, the placeholders, right? Map the placeholder to the values within the string literal. And I'm going to show you what that means. If you don't get what I just said by way of sentence, that's okay. And the idea is so that at the end of the day, you can actually get another string literal, some kind of string form. And I'm going to show you an example. Don't bother if you don't get what I said, but you're going to get it now. To perform a string interpolation, you want to wrap each expression or value within the string literal within a parenthesis prefixed by a backslash. Let me show you what I mean. This is a piece of code. I typed this on Playground, copied and pasted here, right? var year is equals to 2014, right? You already know what that is by now. So if you're reading the code, you already know what that is. Var literally means I'm creating a variable. I have my year. I've given birth to year, but I want to tell you the nature of year. It's a variable year for some reason, right? And then I assigned it to 2014, right? So if I asked you what data type is 2014, by now you should be able to know. And if you don't know yet, all you need to do is go back and ask yourself, what kind of data type are we dealing with? Your data type is an integer. Remember I said an integer is every word or every whole number on the number line, whether it's negative or positive, right? That's an integer. Even though it's not expressly displayed here, you automatically know that this is an integer. If you want to make it explicit when you're writing this code, you just say var space year space equal, not equal to, you be like colon, semicolon, sorry, full colon, then string equals to 2014. But this is the shorthand of how you write this. Then I've written this, right? So I have that expression. Next thing I want to do is, because it doesn't print this out for me to see on the console. That's why we always introduce print, right? Now, I'm trying to create, I have this expression, but I'm trying to create a string. Remember, I told you that's a second way of creating a string, right? And I use what you call string interpolation. What am I doing? I start with my open and close parentheses, and then I put in a sentence there. But I don't want to put in 2014 because I know 2014 is going to constantly change. So if I go put in 2014 here, when this changes, that change does not reflect here. Think of me trying to write an entire chapter of a book, right? And I have to go everywhere there's 20. Once this changes, I have to go everywhere there's 2014 to go change it. That's not efficient. So what I do is I literally create this placeholder slash open and close parentheses, and then I put my year in there. I already have my year. So all this is doing, this mechanism slash, your parentheses, all it's literally doing is it's going to, whatever the value is here, is going to pull that value and put it here, right? So if you print this, it's going to say Swift was introduced in 2014. If I change this to 2011 and print again, it's going to say Swift was introduced in 2014. How am I able to achieve this? By literally creating this placeholder. And this whole process of what we have done here is what you call string interpolation. And again, I mentioned it's very important because I could decide to write an entire book, and I write a code, and maybe the first page of that book, or I have a file where I just put some things so that once I go change them, they are all variables. It will change everywhere, right? I've put a placeholder within that book so that I don't have to go everywhere to go make those changes. That's your other way of creating strings. Any questions? Questions? I don't know what time. Okay, 7:10. I think we are going somewhere. So, excuse me. So the next thing I'm gonna show us is this. Look at another example. Look, just read this example and see what you think. Look at that example and see what you think. Let. Just seeing let there literally tells you it's a constant, because that's how we create constants, by typing let. Let place. Place is my identifier, right? And then this is the longhand. Remember when I told you, you can literally remove colon string and just say equals to Washington, D.C. But a long way of doing it, or rather a way of being explicit about it, is putting a colon and string equals to this. So I've created this, right? So that's me, and this is an example of the string literal that we talked about the last time. If you do this, you create your string literal. What we just finished right now was string interpolation. Next thing that we're going to talk about is your integer. Remember what I talked about the integer? Your integer is any whole number, negative or positive, anywhere along the line, which is like your number line, right? So it represents whole numbers with no fractional components. Now, even though in human speak, 38 is the same thing as 38.0, in Swift, if you 38 and 38.0 are not the same thing. So you need to be careful about that. 38 in Swift speak is an integer. 38.0 is a float. So the int keyword, that's the short, that's the keyword that is used to create integer-like variables, which is what I'm going to show us in the next slide. Computers use the binary system. So that line of code is actually not supposed to be there. That should be in Boolean. So I apologize for that. I'm going to get it out before I send that to you. So this is an example of how you create an integer. Var, which is I'm creating a variable, whole number, that's my identifier, my colon, and then int is equals to 101. How else can I write this? I'll say var whole number equals to 101. That will work too. And then I print, and this is the output I get, 3. No. So this, again, this needs to change. I don't know how I didn't modify this. This is supposed to be 101. So if you print this out, 101. It only becomes 3 if you decide to change the int, and that, I think that's probably what I did. I started with 3 and then I changed to 101, but I didn't modify this. So then the next thing we have is the float. It's used to represent a number with a fractional component. Like I mentioned, anything that has a fractional component is a float, right? Except of course, the fractional component is a very long fractional component, say 15, 12 numbers, 13 numbers, 14 numbers, then it becomes a double. So this is an example of a float. We're all familiar with pi, let pi value. Why am I using let? Because I know pi is a constant. I can't change pi. Pi is just what it is, right? So it's considered a constant. So if I'm writing a code where I want to put in pi, I could just type something like let pi, or I can say let pi value, whatever it is. But the idea is so that when someone reads these, they know what I'm talking about, right? Colon float, right, equals to 3.14159. So if I decide to go say colon integer, int equals to 3.14, the system is going to throw up an error because the system does not identify fractional numbers as integers. Try it when you work on your code in Playground. And then I print out, and that's what I get to. And a double, so like float, a double, the double type is also used to represent a number with fractional components. However, double supports data up to 15 decimal places. So, and then same example I showed there will be what you showed. The only difference is that the same example I showed for float is what you're also going to have. The only difference is that it will be able to accommodate more fractional numbers. And then you have the Boolean. Now, a Boolean data type is used to represent logical entities. That's literally when you're trying to make a decision, right? You say something like Mary is a girl, right? The only answer to that is true or false, right? So in a case like that, you want to use Boolean, right? um, this year is 2036. The only answer to that is yes or no, right? So that's what Boolean does for you. If we don't assign any value to Boolean, the Boolean variable, it actually takes false as its default value. So that's how it's. So if you don't assign anything, you automatically get false. They are frequently used with if-else statements. So again, like I mentioned, it's about decision making, and we're going to go into controls, with your codes and all of that. So look at a typical example of the use of Booleans. This is true, right? Let's assume our identifier is this is true, colon, bool, right? Equals to true. Then you print, right? You have assigned it true, so of course it's going to print out true. Let this equals to false. If you print it out, it's going to give you false. So in this case, we haven't been able to do any comparison. We're just assigning it and printing it out and seeing what it does. That's all we have done here. Then there are certain times, right, where you can, not only do you have your data type, you can actually assign it a method, right? There are a couple of methods that you can use. So this is an example of a method, right, where you say, let all over equals bool, right, dot random. All you're trying to do is, so in programming, right, when you call random as a method, right, what it does, let's say you're looking for random numbers. What it does, it will automatically, every time it will throw up a particular number because it's just randomly choosing those numbers, right? But for bool, because of the data type you have, in bool, you don't have a lot of numbers or a lot of characters or a lot of strings or whatever. All you have is a yes or a no. So once you include dot random, all you are literally doing is, so if I run this right now, the first time I might get it true, and I run it again, I might get a false. So it's going to be vacillating between true and false, true and false, true, false, true, false. And why it's able to do that is just because you have asked it to randomly generate the values of the Boolean, right? So that all over is going to be true, is going to be false, is going to be true, is going to be false. Another way to do that is to use what we call toggle, right? Now, notice that here we did not say equals to bool, but once you type equals to true or false, automatically it's implied to Swift that what you have there is, so true and false are like reserved numbers. You can't, it's like you come to a parking lot, right? And you see some spaces are reserved. Nobody is parked there. All the other parking lots are filled, but you still can't use the reserved spots, because if you go use the reserved spot, you might be towed. So there are certain words. Notice these words that are in blue. They are reserved words when you code, right? They are words that have been designated or assigned by Swift that no other person can use. So they mean specific things to Swift. Whenever you use them, Swift automatically understands them to mean something. So once you have true equals to true or equals to false, automatically Swift knows that you're talking about a Boolean, right? So I'm saying I'm doing a variable and I'm assigning it to this. Excited is my identifier, and I'm assigning it to a Boolean called true. Excited dot toggle. Toggle is almost like Boolean. All it does is it toggles between the two of them. Think of it like the seesaw. You have your brother or your sister when you were a kid sitting on the seesaw, one person at one end. You jack this side up and it goes down the other way, and then it comes back this way, and then it goes back that way. So I think toggle would probably be more like being consistent. It's true, it's false, and random will be like really random. That would be what I think for this. So you print excited and then you get your true or false. So this is an example of you using, for example, Boolean. Let's say I create a constant, right? And I say let A equals to 3, let B equals to 5. And then I say let my answer, right, equals to A is greater than B. So I'm trying to test the proposition that A is greater than B. I've already assigned values, right, to A and B. If I say let this equals to this, if I try to print this, it's automatically going to tell me, right, false. Why? Because 3 is not greater than 5. So that's why it's false. So you get a sense of the kind of situations where you use Boolean. This is a very simple situation of where you use, there are more sophisticated cases. But this is a short way of writing the same thing I've done here, literally where I say let C, comma, D equals to 4, comma, C, and I say let answer equals to C is less than D, and then it answers true. So the other important point to make is there are any number of ways to write a code. There's no one way to write a code. The only thing is being able to know how you think about codes and all of that. Okay, I'm going to stop because I'm done with data types now. Eventually, I'm hoping we will do some data structure. I don't know if we're going to do it in such an organized way, but if I find the time, we'll probably do. So we've done data types. It would be good to do data structures if we find the time to do it chronologically, just like the data types. But if we're not, we're just going to intersperse it in the rest of the class, because I want to make sure we are keeping pace, because we are these 2 to 3 weeks where we've been deliberately slow to make sure everybody catches up. So, hello, is someone asking a question? Hello? Okay. Oh, okay. He's exiting. So, any questions? Awesome. Awesome. Colton, sorry, guys. I'm just reading some of the chats because I was heavily. Okay, so we have about 25 minutes, and what I'm going to do is